If you want to create your first deep learning application for classifying the contents of an image, you've already trained a model and would like to make predictions. In this quick tips episode, you will learn how. Keep watching. Hi there! I'm Manuel Gutierrez from thelighthouse.co, and I make videos that help you learn about different programming topics like AM, Docker, TensorFlow, Unity, and more. So if you're new here, hit the subscribe and the bell notification buttons below so you don't miss a thing. Let's start! This video is part of the ASL classification series where you'll implement a simple deep learning model using TensorFlow and Keras for classifying images. First, we define the problem that we want to solve, identifying hand signs for the American Sign Language ASL. Then, we collect or download some data representing examples of what we want to learn how to classify. Images of hands representing the ASL fingerspelling signs. We define and train a model that can capture, learn, and classify the visual data. We evaluate the performance of the model to see how well it is classifying images. Finally, we use the trained model for predicting hand signs. This video. Don't forget to join the free mini course in the description below. In this video for the Deep Learning ASL classification series, I will take the already trained multi-class classification model and use it for predicting hand signs. I will also point out some weaknesses of the current model. For predicting, I will load some images that I prepared inside the predict folder. I am going to use the same function that I created earlier for this purpose. If we check the predict folder, we will see the same structure as with the train folder, where for each sign we have a subfolder for each specific letter or number, and inside each folder we have the images that correspond to the particular sign. Let's plot the first 5 images that were loaded using the function we created earlier. As before, when training, transform the image array and call the predict classes method from the model and store it inside a variable. Given that predict classes returns integers, we need to use the label encoder to get the string labels. Let's get an array of strings with the real label and the predicted one and plot the images. Now let's explore the results. I took from the training dataset a couple of images that were, unsurprisingly, labeled correctly. Given the performance that we saw when training and evaluating the model, examples here are the 0, 9, B, M, N, R, and the W. Now, I performed some changes to some of them to test how well would the model perform against really simple but unseen images. First, I took one particular image and changed the background. Just to make sure I didn't break anything else, I changed the background from one of them to black again and checked if I got the correct label. Then, for another copy of the same image, I changed the background to another solid color, in this case blue, but given that we're working with grayscale images, it looks gray. Here we got the wrong label. And if you check the other two examples here, where I took the solid black background color from one image and changed it to a non-solid background, I also got the wrong labels. I also moved the image from the center for one example. Again, the wrong label. Changed the size and tried to keep it centered, correctly classified. Alright, so you can see here that the model is amazing. With around 96% accuracy, it is able to correctly predict images really similar to what it saw before with high accuracy. But when we change one little thing, it breaks apart. And that's without even trying with more real-life images. Awesome! Congratulations and thanks for watching! You can join the free mini course associated with this video by clicking on the link in the description below. Share any comments or suggestions about the series or future topics. And if you like the video, also hit the like button below.